Hello friends, today I have got an interesting topic. Let's see, it's 7 divisible by 3. How can you say that 7 is divisible by 3? In the junior classes, what we used to do is we used to divide the 7 by 3 like this, divided by 7 and the 3 to the 6, and then subtract it and get the remainder as 1. Since we left the remainder as 1, so this is not divisible by 3. Or we can say it in terms of computer it's false, or in binary coding we can say it as the result is 0. Similarly, let's see another example. Is 15 divisible by 5? Yes, we can say it's divisible. But how can you say? We are going to divide 15 by 5, then 5 3s are 15, the remainder will give 0, and hence we can say it's divisible by 5. True, or the result is 1. But how can you define that 15 is divisible by 5 mathematically? So is there a mathematical process behind finding this divisibility function? For example, if we input the value of 7 and 3, it will give us 0, so that the 7 is not divisible by 3. And also, if we plug in the values 15 and 5, the result will be 1, saying that 15 is divisible by 5. And the answer is yes, we have got a mathematical function for that. So the topic behind today is the divisibility function. So this is what we're going to learn today. This is the divisibility function. It looks quite complex, but it's very intuitive, and you can easily gain its intuition by going through the examples. And before learning this, you need to learn the concept of limits and some calculus and derivatives. So without it, it can be quite difficult for you to understand. So before proceeding, you need to learn the concept of limits and calculus. So we'll proceed with the examples to make you understand it quite easily. So let's go to the previous example, 7 divided by 3. So this function is such that when n is divided by a, it will give 1 if n is divisible by a, and it will give 0 if n is not divisible by a. So let's consider n equals 7 and a equals 3 and plug these values in this function. So it will be 1 by 3, 10, 7 pi over 10, 7 pi by 3. Since the tangent takes the value 0 when there is an integer multiple of pi, so the numerator part will be 0, and in the denominator part it will be some decimal numbers. So anything, if the numerator is 0, the result will give 0. So it means that it's false. That means 7 is not divisible by 3. Similarly, in the case with 8 divided by 3, we can plug in the values like above, and the same result happens over here. In the denominator part, we will get some decimal number, and in the above part, we will get 0, and the result will be 0. Let's take another example. What happens when n9 is divided by 3? Let's plug in the values similarly. Now, this case is quite different from the other two. Since 10 9 pi by 3 is nothing but 10 3 pi, so the numerator part will also be 0, and the denominator part will also be 0. Then how to calculate its value? So for this, we need to understand the concept of limits. So let's go to this formula. So if the numerator part and the denominator part both are 0, then we get an indeterminate form. So to solve this problem of indeterminate forms, we use a principle called L'Hospital's rule or L'Hopital's rule, whatever the pronunciation is. And in that principle, we take the derivative of the numerator and the derivative of the denominator separately. For example, the derivative of 10 is square of second, so we take the derivative. It will be sec squared pi n, and we derive it with respect to n. Though we are considering these as the discrete values, or it takes the value from 1, 2, 3 and so on, but we are considering these function as continuous, such that the n may take any real number values. So considering this, then we can differentiate it with respect to n, so we get this result in the numerator, and in the denominator we get sec squared pi n by a times pi over a. Since pi over a are the coefficients of n, so it will come out, and in the numerator the coefficient of n is pi, so it will come out. Now we can see that the second takes the value of either 1 or -1 in integral multiples of pi, so the square of it will always give the value 1, and same is the case in the denominator, so sec square pi n by a will always give a value of 1. So by further simplification we will get the result as 1 whenever the numerator and the denominator part is 0. So in the same case, so in the case of 9 divided by 3 also, we will get the numerator as 0 and the denominator as 0, so we can apply this rule to get the result as 1. It means 9 is divisible by 3. So let's see another example, 15 divided by 3. First we plug in the values and we will get the indeterminate form, and we will find the value to be 1 using the concept of limit. So it means 15 is divisible by 5. Similarly, 17 divided by 5, it will give this value, the numerator will be 0, and then it will result in 0, which is false. Similarly, 18 divided by 5, we will get this result. So here is 5 not 3, then it will give 0, and again give 0. This is 18 pi, and which is false. Now we have already learned that in the concept of limit, if the numerator and the denominator part are both 0, we can differentiate in the numerator part and the denominator part to get the result as 1. But is there another way of representing this function? And the answer is yes. We can represent this same function with the help of sign also. But there is one problem behind using sign. Let's see what is the problem. Suppose we consider the function as represented by this equation, then we can simplify it as follows. When the numerator and the denominator part is both 0, by using the concept of limit, the derivative of sign is cos, and the derivative of sign is again cos in the denominator. Since pi is the coefficient, it will come out, and pi by a is the coefficient in the denominator, it will come out. And the problem here is, since cos can take either the value of 1 or -1 in the integral multiples of pi, so we don't know in what numbers the cosine is 1 and in what numbers cosine is -1, so it becomes difficult for us to calculate the value. So what we use is, we use the modular sign. So if the cosine is -1 also, it will give the positive sign. So hence, by using the absolute value, we can easily find the same result as obtained from here. So instead of using 10, we can use the sign function also, but remember to put the absolute sign in here. So as a conclusion, what we can say, that if we have two numbers, then to check whether the first number is divisible by second or not, we can simply use this formula. Now let's look at the graph and how it works. So this is open software called graph, where you can easily draw the graph of different functions. For example, the first function is the function that will say whether a number is divisible by 5 or not. So I am going to check on this mark, and you can easily see here from this graph, at point 1 the result is 0 because 1 is not divisible by 5. At point 2 also the result is 0 because 2 is not divisible by 5. Similarly, in the case of 3 and 4 also the value is 0 since it is not divisible by 5. And whenever the value 5 comes, the graph shows the coordinate of 1. That means 5 is divisible by 5 itself. Similarly, you can see at the point where there is the multiple of 5, like 5 and 10 and 15, the y value is 1. That means these are the number that are divisible by 5. And in other numbers like 6, 7, 8, 9 and 11, 12, 13, 14, the value is 0. That means it is not divisible by 5. So it is by using the tangent function. So what if we use the sine function? So let's uncheck this and let's check this using sine function. The graph is different but the result is the same. As you can see in the values of multiple of 5 like 5 and 10, the value is 1. And in the value where the numbers are not divisible by 5, that is 4, 3, 2, 1, 6, 7, 8, 9, the value is 0. That means it is not divisible by 5. So you can do by both methods, the result is the same. The graph is different because we actually don't need the value in the middle portion or in the decimal part. We only need the values in the integral part. So by using either sine function or tan function, we can get the same result. So it's all about the divisibility, and thanks for watching.